today I'm going to be talking about whether or not you should create your own data science library. So quickly, by way of introduction, my name is Piero Ferrante. I am the principal data scientist at Aetna. Aetna was recently acquired by CVS, so we say Aetna, a CVS health company now. I also advise a healthcare startup called Play It Health on algorithms and data strategy. My background from an academic standpoint was in quantitative finance and predictive analytics, applied machine learning. Spent about 10 years hopping around different industries, but the majority of my time has been in healthcare. Really great field for individuals that are strong in tech and want to solve really big, hard problems because healthcare is wrought with them. And I do some teaching on the side. I have an invention, which I'm proud of, and I used to organize a big data science meetup in Kansas City. Something that I tell people about myself, and then they're like, oh, that's interesting. That was like the most interesting thing you told me, was I take apart mechanical watches and I put them back together. So some people find that cool. I don't know. It's just something I've always done. I like to understand how things work. So enough about me. I want to know a little bit about you all. Who in this room, by show of hands, writes the code? All right, a lot of people write the code. Great. Who is classically trained as a computer scientist? Show of hands. All right, so maybe about 1/3 of the room there. And who here has contributed to an open source project? All right, the numbers are getting smaller and smaller, but there are a handful of you. Thank you very much. And who here has authored their own library? Brand new project. All right, 1, 2, 3 people. All right, cool, congratulations. So maybe some of this will be familiar to you. Maybe you went through some of these same thoughts along that journey. So before I get into it, I just want to say a little bit about Aetna. So we're a large health insurance company, right? We're in the business of keeping our members as healthy as possible. The healthier our members are, the better it is for us, right? When CVS acquired us, CVS, in long story short, they're taking a very long position on health. You might remember that CVS stopped selling cigarettes in their stores a while back, a huge revenue hit, but they're all in as a healthcare company, a health and wellness company. So what my team and my department focus on are creating better health-related outcomes through, we build a catalog of different actions. So it may be something very innocuous like, hey, have you taken your 10,000 steps today? But on the other end of the spectrum, it might be more clinically involved. Perhaps you suffer from a chronic respiratory disease and you haven't seen your pulmonary specialist in the last several months. And by the way, you forgot to pick up your inhaler at the pharmacy last week. So we'll try to engage these members over a host of different channels with different behavioral economic principles in our messaging so that we can encourage behavior change for those members. And we do this at scale. So I think Aetna, last time I checked, about 24 million members. So when we're running these large controlled experiments, we're really doing it at a massive scale. All right. Does anybody know Francois, this gentleman? Works at Google, contributes to TensorFlow, and he tweets really intelligent things. I like this tweet from the other day, and I sort of worked it into my talk. But the piece that I was interested in is the first bit. A way to describe intelligence is that it is the power to produce abstraction. So I'll be focusing on abstraction a little bit in this talk. And it's really difficult to create abstractions because you have to have a great appreciation and understanding for the lower level intricacies to create that abstraction. That's why teaching things is generally difficult, because you have to understand all of those things and then regurgitate it in a very approachable way, which takes a bit of effort. And we're all about abstractions. So if you go back in history, on the left you have the abacus, simple adding and subtracting machine. In the middle there you see Charles Babbage's analytical machine, which was actually an incomplete work. He never quite got it finished, but it was an abstraction on lower level, more tedious types of computation. And then on the far right, you see an early computer. So why are we interested in abstraction? So I don't know about you, but every day I have 24 hours, right? I don't have enough time. The older I get, the less time I have. And abstractions can afford us greater productivity, which is important day to day as a data scientist, especially when we're doing a lot of monotonous and redundant tasks like cleaning data, introspecting our models. So when we have the ability to leverage an abstraction, it's in our best interest because then we'll be more productive. And generally speaking, as you become more abstract, you can achieve greater productivity. So some examples involving different levels of abstraction. Machine code, right? That's the most basic level, dealing with binary. And then you have assembly language. Has anybody here ever written assembly language? Any of the CS grads in the room? All right, a handful of you. Did you enjoy doing that? Do you reflect fondly on those days of writing assembly language? Okay. You kind of liked it, I can tell, in the front row. And then you have lower level languages, like C. Sometimes I ask a silly question during interviews, what's your desert island programming language? And most of the time, I'll get the answer like Python or something. But every now and then, you get somebody who mentions C or C++ just because you can do anything under the sun, essentially, if you understand those languages inside and out, which I appreciate. And then you have higher level languages like Python that create opportunities for people that don't want to spend their time writing assembly language or don't have the wherewithal to learn the ins and outs of C. But they're still capable developers, capable creators. And Python creates an approachable higher level language that you can look at and read, and it kind of makes sense, right? That's pretty cool. As I was doing research into different higher level languages, I came across some obscure ones like Mu. And there's another language which apparently is just an amalgamation of Arnold Schwarzenegger movie quotes. And it's like a standalone high-level language. So if you don't have anything to do this weekend, I would explore that. And then on top of Python, of course, you have libraries. Libraries that we celebrate and use every day, like NumPy and Pandas and scikit. Right? Why does everybody love scikit so much? Because it has such a clean API. It makes looking at a machine learning pipeline very easy to understand. This happened, and then this happened. And then I can inverse transform all of my great feature transformations. And I can call a fit method. And it's very approachable and standardized. And it gives way to greater productivity. So what I'll be talking about today is a library that we developed in-house called PyConnect. It's not applicable to individuals outside of the four walls of CVS and Aetna. And that's perfectly okay. I'll walk you through why it was worth going through that exercise for us. I've spoken with several individuals over the past couple days, or over today and yesterday, about different projects that they developed in-house that just make sense for that business, and it's become a core part of that business. And that was really the inspiration for PyConnect for me and the co-author, who I'll mention in a bit here. So I have to make a joke about recreating the wheel here, because it's worth asking that question of yourself. You don't want to just write some code for the sake of writing code. Well, sometimes you do. That's fair enough. Sometimes you want to do that. But I'm getting paid to do what I do, and I don't want to waste people's time. I don't want to waste my company's money. So it was a prudent exercise for me to think about, did we really need this? Am I just recreating the wheel? Is this something that will continue to help others be more productive and generate value? So you have to ask yourself this very basic question. Do you feel the pain? Is there enough pain that warrants the time and effort that goes into developing a library like this? I'll talk you through a couple of our pain points. So our data science organization is growing a lot. It's 3x in the year and a half since I've been there. And we're bringing in talent at all different levels. So some folks just coming out of grad school, some folks coming out of undergrad, and some seasoned professionals that have been developing software for over a decade. And different individuals have different needs, have different proficiencies. So for some of those individuals that were less seasoned, we needed a way to get them productive sooner rather than later. And I didn't want them bumbling around, with a conda install for the very first time. Do I pip install? Do I conda install? Which version do I use? Wanted to get through some of those details, or kind of abstract away some of those details. Another problem that we were facing was that our Hadoop cluster was running on an older distribution of Hortonworks, actually. And some things are in your control. If I'm a root admin, I can go ahead and pull out all the plumbing, and I can change things. But when you have 50, 60 petabytes of member information across 100 million lives over several decades spread out on that cluster, you can't just pull out wires like that, right? And there are reasons, defendable reasons, why it may have taken a longer time than I would have preferred to update that distribution. But I had to figure out a clever way to work around some of that, because as 2.7 won't be supported for much longer. A lot of libraries have already formally announced that they're no longer supporting older versions. And I want the data scientists on my team to use new libraries that leverage higher levels of abstraction to accomplish more and introduce new features. So that was another problem that we were trying to overcome. We also have a bunch of different databases, like you name it, and we probably have it somewhere. Anything from MS SQL to Netezza to all the data spread out on our cluster to a DB2 warehouse. It's all over the place. And some of these different databases require different means of connecting and extracting that data. So that was something that we needed to solve for as well. Who here has messed around with Spark or Hive configurations at one point or another? All right, there are a fair amount of you. And there are a lot of different parameters that you can set with your Spark and your Hive configuration that have a material impact on the way that your job is going to run. So how do you kind of instantiate a best practice from the get-go for a data scientist it's their first time working on a Hadoop cluster and submitting a Hive query? You can work around some of those things by creating clever defaults that are sort of hidden away. Multiple installation directories and jars all over the cluster, which is the latest installation of this or that, very messy. And we needed a way to point to the right resource for the right job. And lastly, the last two things here, users can suboptimally persist data. So there are so many different ways that I can create a Hive table. I can write a big wide CSV out to my local home directory, and then I can move it over to HDFS, and then I can issue a Hive command to go ahead and create that table. But there's so much waste in what I just told you, like why CSV? Why did you put it in your home directory? When you created that table, were you using compression? Were you being smart about partitioning opportunities when creating that table? Things that you may not think about the first time around, but when you're not really paying attention to those things over time, it can really add up. So we wanted to, again, abstract some of that away. So we created this project called PyConnect, which to my dismay, was actually already out there on PyPI somewhere. So sorry, whoever initially created PyConnect. And the way that I describe PyConnect here, it's a package designed specifically for data scientists, analysts, and engineers at Aetna. Very, very specific about that. It aims to make you more productive, faster, by abstracting away cumbersome installation and setup details, like creating your conda environment, locating certain endpoints, setting global variables, and things of that nature. And if you're interested, this is my co-developer, Bing Wei. And I'm sure he won't be happy about me using his picture on the slide either. He's a great guy. All right, so let's talk a little bit about PyConnect. You can go ahead and clone it from the Aetna repo, enterprise repo, if you're working at Aetna, of course. And then there's command line installation. So what were some of the key motivations and objectives for what I was trying to do here? I've mentioned a few times that we wanted to accelerate user productivity, of course. In the interest of leveraging abstractions, we wanted to hide needless complexity. With the example that I mentioned a minute ago about writing out a Hive table, we want to promote some standardization to reduce inefficiencies. The fourth point is an interesting one, and I'm sure for those of you that have developed your own libraries at one point or another, it will probably resonate with. You introduce opinionated best practices. Maybe best practices isn't the right word, but when you're writing software, you're expressing your opinion about what you think is the right way to do something. And of course, you can always poke holes in it and challenge whether or not it's universally applicable to every problem under the sun, and it may not be, right? But that's part of doing it. You have to kind of draw a line in the sand. If you try to be everything to everyone, your scope will get out of control, and then you won't effectively do what you set out to do in the first place. So there's some opinions that get baked into these types of projects, which kind of works into the fifth point about 80-20ing most of the use cases. I wasn't trying to solve for everybody. I know some people will send me an email and say, oh, why doesn't it do this, or raise an issue. Well, okay. We'll consider that as a feature in the future, but wanted to solve 80% of the use cases well and not 100% of the use cases not so well. And again, some of the constraints that we were trying to overcome: individuals with varying levels of proficiency. Everyone can't be an admin, nor would I ever suggest that they try to be. All the different databases and multiple software and compatibility issues. All right, so who's my target audience here? I mentioned data scientists and the business analysts and data engineers and consultants, but not the hardcore programmers. I'm the type of person that will go into the code and try to understand how everything's working, and some things I may want to configure a different way. For example, like your Spark configuration, sometimes you need a lot more resources and sometimes you don't. So you need to occasionally go underneath the hood and mess around with some things. And again, this wasn't for hardcore programmers. The hardcore programmers will know how to install those libraries on their own and do some of the things that the library sets out to accomplish for others. So for those of you that are developing software for others or managing a team of data scientists or analysts or engineers, you want to position your team to be successful. You don't want to just send them out into the cold world and say, hey, good luck. You don't want to send them up a river with a blindfold on, right? You want to position them to be successful and give them the tools that they need to be successful. You also want to position them to be productive. I'm going to harp on that point quite a bit. Does anybody know what this is? What was that? Spark error. Yeah, this is a beastly Spark error. Who here likes troubleshooting Spark errors? Nobody, right? It is awful because it's an abstraction wrapped in an abstraction wrapped in an abstraction. You're probably using PySpark, and it's really difficult to understand exactly what went wrong on the JVM. So, we tried to avoid that situation. So what were some of the core features that we wanted to build into this library? First off, we wanted to get the installs right. Get a data scientist starts, I want them, writing some code, exploring our data within the first week. So it manages the conda build. It goes ahead and it sets up Jupyter for them. Privacy and security are of the utmost concern in healthcare especially. So passwords and things like that need to be encrypted and decrypted when we're doing authentication, et cetera. We also wanted to avoid having them hunt and peck for the right endpoints, the right jars all over the edge nodes or the cluster. So we were able to set up some of those global variables that are used to either build connection strings or establish a connection for them beforehand. And we also introduced a set of standardized aliases, which is good because then everybody's talking the same language. Who here has ever compared their bash RC with a coworker? Right? It's like everybody always has their own crazy aliases in there, and when you're trying to troubleshoot something for someone, sometimes you have to go back and undo the ball of rubber bands and hair and bubble gum, and it's awful. So we wanted to get away from some of that and standardize some of those things. And then for querying data, this is the biggest thing for me as a data scientist. It needs to be really, really simple to get at the data. If you can't get at the data, it's our currency, right? The more difficult you make it for a data scientist to access the data, the lower your return on investment is going to be for your whole team and whatever you're working on. So we wanted to expose a really, really simple API for querying those multiple backends. We also wanted to afford users the ability to submit asynchronous queries where applicable. Standardized column names. Has anybody ever had that DBA or whatever that creates some column names with lowercase then uppercase? Sometimes they'll use a space, sometimes they'll use an underscore, and then you're looking at your features in your model and it's all over the place. So there's a bit of column standardization. Next one is big, especially if you work on, for us, our analytical sandbox are these edge nodes that are connected to our cluster, which have a lot of CPU and a lot of RAM. But if everybody's holding these massive data frames in RAM, you're going to have some trouble at some point. So by doing some intelligent downcasting behind the scenes, like converting strings to categoricals, by doing some basic inference about how many unique values show up in a given column, and converting large numeric types to smaller numeric types where applicable, you're able to drastically reduce that memory footprint. And the user never even knew that happened, right? They didn't know that I just downcasted their string to a categorical, but we're all the better for it. And the last piece, which is sort of a work in progress, is a feature builder API. So in healthcare, we're pulling in data points about your prior medical utilization, your consumer patterns, your social determinants of health, demography, pharmacy information, retail information, you name it. So when you're building a model, instead of hunting and pecking again for hundreds and hundreds of different variables, wouldn't it be nice to just say, here are the unique identifiers that I want to pull back these attributes or features for within a time span, and give me back pharmacy data, demography, and medical utilization. And then it will kind of auto-build those queries behind the scenes. So that's another piece that we're working in. Persisting data, I mentioned that before. Instead of doing all those different hops and then creating an uncompressed, unpartitioned table, we can just write a Parquet file directly out to HDFS and then do some smart DDL to create that table. So we're reducing a lot of overhead by doing that. Efficient distributed computing. So how do we get past this whole 2.7 limitation while using a Python 3+ environment? There's a library called Skyne, which will essentially take a tarball of your Conda environment working on an edge node and ship it over to your cluster. So then we can run Spark jobs with the latest and greatest PySpark, which is using Python 3+, without being limited to the Python 2.7 that's on the cluster. So it was a clever way to kind of work around the distribution on that cluster while affording our users the ability to use more modern libraries. I also mentioned the Spark and Hive default configurations before. So that avoids a data scientist from using too many resources when they don't actually need them. and other niceties, boilerplate code, and some simplified imports, because nobody likes a cluttered namespace. So since we are at PyData, of course, it's worth calling out some of the libraries that made all this possible, some of the abstractions that we're leveraging to build our abstraction. NumPy, Pandas, PySpark, Jupyter, PyHive, H2O, PySparkling, Dask, SQL Alchemy, PySQL, and IBM DB. Has anybody used that one? Any DB2 users out there? Okay, I don't think so. So what does some of the code actually look like? You can see on the left-hand side, I mentioned we were trying to build a really simple querying API that's backend agnostic. So, a user would just import pandas as PD, PyConnect utils as PU, write some SQL, and then they can say query DB, pass in their SQL, specify the backend, and whether or not they would like a data frame back. Because sometimes you're just issuing like DDL or something like that. So pretty simple. But behind that is a lot of stuff, right? I mentioned the Spark configuration. I mentioned the Hive configuration, the ability to talk to different backends, the intelligent downcasting, all that stuff behind the scenes, and my end user doesn't need to know about it unless they want to. So this quote here, simplicities are enormously complex, Richard O. Moore. I'm actually using it a little out of context. Does anybody know who Richard Moore is? He's a poet, and this was about love. So I'm sure he didn't intend me to use it in reference to like API development, but I thought it was applicable. So what you see on the surface, 3 simple arguments. What's hidden beneath the surface? A bunch of needless complexity for 80% of my users. Which version of Python am I using? Do I need to worry about Spark compatibility? How should it be configured? What's my connection string look like? Can I use good old SQL Alchemy, or do I have to use IBM DB? Bunch of important stuff, but not so important to the end user. Another example for writing to Hive, you can see, again, just write to Hive, pass in the data frame, specify a table, and then 2 simple operations, create or append. Of course, life is more complex than create and append, but most of the users, again, 80-20, that's what they're doing. One of the, creating a table, I mentioned before, compression, partitioning opportunities, those are things that you look for in an optimal world. But when you're appending, who here has ever done an append or tried to do an append using Spark, and then you get an error because your data doesn't line up with the data that you're trying to append to? It was happening quite a bit for some of our users. So one of the neat little things that we worked in was just doing some schema inference. So quickly ping the table, the target table that you're trying to append to, take note of the schema, and then run a quick schema transform on the data that you are about to append to that table. Again, the user doesn't know that it's happening. They don't realize that I had a float, but I'm trying to append to a table with an int, but it just works. So there is a downside to abstractions. Of course, it can't all be golden confetti here. So when you do climb that complexity ladder, or that abstraction ladder rather, you give away a little bit of control, right? The low level extensibility that you have in a C, you don't always have in a Python, which sometimes is good, sometimes is bad. But as long as you're transparent about that exchange up front, and you acknowledge what some of the trade-offs are, you're well positioned. And the really, really good software doesn't necessarily always have to make that compromise. So, in earlier versions with like PyTorch versus TensorFlow, the first version, a lot of users like PyTorch, because you could go in there and you could change things around a little bit more. You could introspect your models. So there are ways to have your cake and eat it too, but it takes more time, effort, and foresight. All right, so was all this stuff worth the time and effort? I'd say so. Based on some really oversimplified calculations here, like on the left-hand side, taking into account what the value per minute of our data scientists are based on like a mean salary, how much time we're saving them with the initial startup costs, so avoiding that cold start by handling, somebody's doing the math right now, right? Handling the installation, getting them going, the daily speed up in minutes by not having to write some of these functions from the ground up and being able to use boilerplate or high-level abstractions, accounting for approximately a year in work days with a really low-ball estimation of the number of users, because I think we're at about twice that for the PyConnect users in-house, and then just a discount factor of 50% because I'm a nice guy. And we can see non-trivial annual savings for the effort, which is nice. You want to make sure that it's all worth the effort in the end. So should you develop your own library? I would consider these 4 questions. Is there a legitimate need? Right? That's the first question. Do you feel that pain? Does that pain exist? Does something already exist that you could potentially leverage? You don't want to reinvent the wheel just for the sake of reinventing the wheel, unless you're intentionally trying to learn something new. And do you have the expertise or willingness to see it through? Just creating v1.1, putting it out there without any supporting documentation, and then you don't answer any of the emails or look at any of the issues, that's not really the responsible way of going about it. So you need to have a little bit of wherewithal to see these types of projects through. And lastly, is the juice worth the squeeze? Are you creating value for your users or your organization or whoever here? So really, that's it for me. And if you have any questions, I'd be glad to take them. Yeah, you can just raise your hand.
Yeah, I was wondering if you could talk a little bit about how you convince your manager or other stakeholders in the organization to support this. Is this something that you built on your own and then sold to them, or got there by it first? And if this is something that you're doing like as a full-time part-time job or a side project full-time?
It's a good question. So as far as like buy-in is concerned, if I have a really good widget, I don't want to force it upon you. I want you to want to use that widget. And a lot of the inspiration for creating the library in the first place came back to common pain points. So, when one user started using it and then things worked, then another user starts using it, and eventually that user base grows. I am afforded a little bit of my time to solve problems like this and kind of create scalable solutions within my organization. So at the beginning it was kind of off the side of the desk, but once I had a version out there that people were using, and you're measuring the value and you can quantify the value that you're creating for the organization, and how you're incrementally making each data scientist just a little bit more productive, then it really warrants setting aside some hard time to continue the development. Yeah. Yep.
If something in the library needs to be changed or updated, like who's responsible for that? Is it like whoever solved the problem, or is it like part of your sprint planning? Like, how does that make maintenance work?
Yeah, that's a good question. So typically, either Bingwei or I will, make the change. We're constantly looking at any issues that may arise or fielding emails from our users, but don't want to put up walls. I want to encourage everybody in the organization to take ownership of something like this. So anybody can put in a pull request if they have a feature that they want to add. Given that our culture is not necessarily one of software developers from day one, I would never stand in somebody's way who wants to contribute to a project like that and prohibit their growth. So maybe that changes at a certain state of maturity, but it'll be a happy day when there are so many people that are issuing pull requests that I have to say no. All right. Well, thank you very much. Oh, another question.
It looks like your library covers a lot of ground in terms of like a lot of different concerns. Have you thought
Hadn't thought about that, but if there are aspects of what we've developed that are interesting and useful to people outside of our organization, then I would be glad to open source any of it. You know, with the one thing that comes to mind, you know, the high-level API for querying a bunch of different backends, but then there's a lot of maintenance that needs to be done when one of those underlying libraries changes their API or introduces some new functionality. So I could see that becoming like, you know, a large time commitment. But, you know, if there's good reason to, I would love to open source any bit of it. All right. Well, thank you all very much.